Welcome back, Honors Algebra 2. Algebra 2 students, we are on 8.4, which is on page 233 of your student journals. That's where we're going to kind of start. I want you to grab your formula page. If you haven't already, don't have that handy, you want to grab that. And you may need some extra paper today as well. Okay, so I'm on page 233 of your student journals. We're actually going to maybe add in some examples here, so hopefully we won't need a whole lot of extra paper, but we'll see. All right, so on this, what we're talking about is, so the first, I guess, vocab term is it talks about a partial sum. And so what this means is the sum of the first n terms of an infinite series. All right, so in our last video, what we talked about was this idea of a finite geometric series. So finite meaning that there was an end that we could add, if there's 26 terms in the sequence, we wanted to add them together so we could add 26 terms of the series, right? Well, there's actually a way for us to figure out the sum of an infinite series. The partial sum is the sum of the first, however many terms of an infinite series. So for example, if there's an infinite series, but I only wanted to add the first, 27 terms, that would be what we considered a partial sum. And so basically what you're going to notice here is that when we add a partial sum, that there's going to be, it's obviously partial in the sense that it's not going to be 100% accurate, right? So it's not going to be the full sum of the series or for this particular one. There is a formula that we're going to use to represent an infinite geometric series. And what that is S equals a sub 1 over 1 minus r. So what I would like you to do is grab your page. And under where it said finite, we're going to add in an infinite one. So there is a way for some different series. Let me write this down. So there are some ways possible for certain geometric infinite series that you can actually find the sum. And so what I want to walk you through is just kind of how that's possible, right? Because it seems not intuitive, right? How could you find the sum of something that's infinite, right? You would never end. How would you be able to figure out the sum? So we can always figure out a partial sum. That's kind of what we were talking about in this first section, right? We can always figure out a partial sum, and that just means that we're adding up a certain number of terms in the series. But if we want to figure out, there are some ways to figure out the sum of an infinite series. And so let me show you an example. So in this one, I'm giving you, it's a geometric, and I know that because it's being raised to the power. It's infinite because my ending term is here. So what we're looking at is if I expanded this series out, so in other words, I plugged in 1 in here, I would get 1/10 times by 3, 0.03. If I plugged in 2, I would get, let's do the math here, that's 1 over 100, so I'd get 0.003. If I plugged in 3, I would get 0.0003. And what you might notice is that this is going on and on and on and on and on forever. Well, if I added these together, what do I get? I get 0.3333 repeating. This is 1/3, which represents the sum of that particular series.